Okay, everyone, this part of or this video is talking about describing a vector, and the subtopics that we'll see are what is a vector, uh, how can we describe it, what are the different ways that we describe a vector using bearing, using x-axis, and then using northeast southwest axis, and as well finding components. So those are the kind of the subtopics that this video will cover. And let's start initially with what is a vector. A vector is a physical quantity that in order to describe, you need to identify the magnitude and the direction. So this is the definition of a vector. But what does that mean? So in our world, we have two type of physical quantities, vectors and scalars. Scalars are quantities like that doesn't need a direction to describe them. So if you're saying that you were running at 15 meters per second, that means it doesn't need to say in which direction you were running, northeast, southwest, or 20 degrees, or so and so. But when you are saying that the speed in which you are walking was 20 meters per second north, then you are describing in which way you are going to, the direction that you are going to. So in order to fully describe a vector, you would need the magnitude and direction. And in order to describe a scalar, you will just need the magnitude with units, of course, but the magnitude is the one that you need to define. So vector quantities, you have talked about this even in Science 10, but vector quantities are quantities like velocity, and the units for it are meters per second, and the corresponding quantity on scalars of the velocity is speed, and again the units for it are meters per second. Another vector quantity that we will talk a lot on physics is acceleration. And the unit for acceleration are meters per second squared. And there is no corresponding units for scalar in terms of acceleration. Then another unit or another physical quantity that we describe a lot on physics is that is known as the displacement. And the units for it are meters, and the corresponding quantity of displacement in scalar is distance. And the units are meters as well. There are more of vector quantities that we will talk, especially on the second part of the second unit of physics 20, and those are forces. And the units for force is newtons, and then we will have field strength. Different field have different units, but what we will see is that those are vector quantities. Okay, So now when we are describing a vector, there are different ways to describe a vector. The very first one that is used in the world is that is known as the bearing. What bearing is what is the angle that it is measured clockwise from north to the vector. So now, usually we think that north is up. Okay, and if we have a vector that looks like this, vector A, with a magnitude, let's say 20 meters per second, then the bearing will be the angle between the direction will be between the north and clockwise to the vector. This one here. If this angle, let's suppose, is 55 degrees, the way that we describe vector A is vector A. So A with that little r on top is telling us that we are dealing with a vector. And we start with the magnitude along with the direction at bearing 55 degrees. On this way, what we know is that the angle that is formed between the north direction and the vector clockwise is equal to 55 degrees. And the magnitude of this vector is 20. So even on this definition that we have here, we always will see two parts on describing the vector. Is the magnitude with units and the direction. This one here is the direction. The magnitude and the units for a certain vector doesn't change. This is how the magnitude of the vector is. This is how we represent the magnitude of the direction. The way in terms of the direction is in different forms. Bearing is one way. Another one is with positive x-axis. You know that from math that we have two axes, Cartesian axis, x-axis and y-axis. What we will use on physics in terms to describe a vector is just the positive axis. So where they intersect is 0, 0, and then whatever is on the left of the x-axis is negative, and whatever is on the right is positive, and whatever is up for y is positive, and whatever is down is negative. So what we will do in this case is we will just take this positive part of the x-axis. So x-axis like this. And then if we have a vector that is a vector A, that you can say 20 meters per second, and I will keep that 20 meters per second, creating with the x-axis what is 90 minus 20, 90 minus with 35 degrees. So now when we are describing this vector using now the positive x-axis, we'll say 20 meters per second at 35 degree with positive x-axis. And again, we are talking about the same vector, but in two different ways to represent this vector, to describe this vector. You should be able now to move from the English description of a vector into representing it graphically. So let's suppose that we have this example. We have vector B that is 12 meters per second at a bearing of 42 degrees. When I'm giving you this vector and I'm asking to represent this vector graphically, then what do? Is you will draw north axis, and then your vector will be vector B, and the length of this line segment will represent the magnitude of the vector 12 meters per second. And now you will move to bearing. So it is clockwise at 42 degrees with the north axis. So this will be how you will represent the given vector. Or if I'm asking you something like this, vector C is equal to 18 meters per second squared at 120 degrees with positive x-axis. So then the way that you will represent this vector is here you have the positive x-axis and 20 degrees will be something like this. And this line segment, the red one that you see here, will represent 18 meters per second squared through scale, whatever is the scale that you are deciding to use for this purpose. The third way of describing a vector, is that is using north, east, southwest axis. So north, east, southwest axis. North, east, southwest axis looks something like this. And now that means that we are dividing or creating 4 sectors in our plan. One that is between north and east, one that is between north and west, one that is between west and south, and the 4th one that is between south and east. When we place a vector will be most likely in one of those 4 quadrants or in one of those 4 lines. So let's see the case when it is on the line. If we have a vector A, that is 20 meters per second due north, then what we will see is a vector that is straight up north. Okay, the line segment that represent the vector graphically will be 20, will represent 20 meters per second, and the direction is north. And when we have a vector that is saying vector B, that is 18 meters per second due east, then vector B will be represented like this. Now you get it, so that when we have a vector that is vector D, let's say, that is west, then will be, let's suppose, 18 meters per second due west. And last one will be vector C, that is 12 meters per second due south. So when they lie on those lines, then this is what you have. But the question is, what if we have a vector that lies somewhere in between north and east? How are we going to define or describe this vector? So in this case, what we will do is we'll have this as a definition. So we'll have the vector, whatever is the vector, vector A, vector B, vector C, or any vector. And then we will have a part that is describing the magnitude along with units. And then we will have direction, which is now in two parts. One that is the angle. And then we will have two of the four quadrants, north, east, south, west. So we'll have north, east, south, west, off, and then here we will have whatever, east, west, south, north. East, north, south, west, south. So this will define the direction. Let's do some examples, and then this will make more sense. So let's suppose that we have in northeast, southwest, we have a vector A that has a magnitude of 15 newtons. And then we have at 30 degrees north of east. So this is the definition, the English part of this vector. Now, from the reading, we see that the vector has a magnitude of 15.0 newtons. It is a force. How do we know this? Because we have newtons here, and newtons are the units for the force. And then we have the direction, 30 degrees north of east. So now I will just take this, 30 degrees north of east. The way that we define where the vector lies on, what is the angle 30, is the angle with north or the angle with east, is by asking ourselves those kind of questions. For the answer to the first letter is, or the answer to that gives us the first letter of the description is saying where is the vector going? Where is the vector going? So you know that it's going east, sorry, north. It's going north. Now, when you are north, so you are up here, this is where you will go. You can go to north coming from east or coming from west. The second letter is the answer to the question, starting from which point? Starting from which point? So, as I said, to go to north, you have two ways. You can go west or you can go east, from east. Now, the description, the English part of the vector is telling us that you are going north starting from east. So the angle is 30 degrees. This part here, the angle, is telling us by how much. So if we have a vector that I'm telling you as a definition of this vector will be vector B that is 82 kilometers. So this tells us that we are dealing with a displacement vector at 55 degrees south of east. Okay, so we are on the southeast quadrant. Okay, south here and east here. We have a vector that has a magnitude of 82. And now, where is it going? It's going south. Again, to go south, you have two ways. You have west and you have east. Starting from which point are you going south? Starting from east. So imagine that you have a vector that moves from east and it is going to south up to how much? 55 degrees. And the line segment that represent the vector, this one here with an arrow, because this is how vectors are represented, is 82 kilometers. Okay, so now let's take another example. Let's do another, or see another example. Let's suppose that we have a vector C that is 73 meters per second at 22 degrees east of north. Good. So now we are between north and east. Okay, north and east. So north and east. Where is the vector going? The vector is going east. Okay. Starting from which point? Starting from north. At how much? 22. Let's make it with the red one. Vector C, that is 73 meters per second at 22 degrees. This is important to know because you will see when we do the other examples or the examples on even on this lesson when we will find components of the vector. It's very important to define and to know which one is the angle, okay, and what that represents. So this length here is representing 73 meters per second in that case. What I will do now is I will give you some examples, and you can pause the video after I give you the examples and do them in your paper so that you can see your understanding. So let's suppose that we have vector F1 that is defined, is described in English as 25 newtons at 35 degrees south of west. So this is one. Number two is F2 is 32 newtons at 43 degrees west of north. Now, the example number 3 will be F3 equals to 27 newtons at 30 degrees east of south. Next example is F4 equals to 18 newtons at 40 degrees north of west. Number 5 is F5 equals to 22 newtons at 42 degrees west of south. So for now, pause the video and complete those in a separate piece of paper, and I will do them and you can compare them after me. So this is what you should have for F1, the angle with west, and then for F2, the angle with north, for F3, the angle with south, for F4, the angle with west, and for F5, the angle with south. So the last letter is where you have to start the angle from. If you do not have those pictures, then you have to stop, review the video again, and this part of the video, and then understand it. If you still don't get it, then you'll have to ask for help. Now, for the last part of this video, what we will see is how can we find the components of the vector, the horizontal component and the vertical component of the vector. And we can take any one. We can take vector, any vector, one of those vectors here or anything. But the steps will be all, for every case, will be the same. So step 1 will be create a right angle triangle, that includes the given angle. Includes the given angle. Whatever angle is it given. So if this is with west, then create the right angle triangle with the given angle. It is easy to do it on this way. There are different ways to do it, but trust me, this is the easiest one. And then using SOHCAHTOO, find horizontal and vertical component of the vector. So if you don't know this, then take a look at the trig review video that we have on D2L and on Google Classroom. With those two little steps that you see here, you will be able to find the components of any vector that it's given. Okay, so let's take now a vector, pick a vector, and say we are dealing with vector A that is 18 meters at 30 degrees west of south. Let's represent this vector on northeast southwest axis. So we are dealing with south and west. The vector is, the magnitude of the vector is 18. So the line segment that represents the vector is 18 meters in this case, and the angle with south is 30 degrees. Okay, now I said here, create the right angle triangle that includes the given angle. The given angle is 30 degrees. From the tip of the vector, you have two options. You have the option to create a right angle triangle that is along the west axis, or the right angle triangle that is along the south axis. Since I'm telling you that you have to go with the given angle is the angle with the south. So the right angle triangle that you have to create has to be something like this. Okay. Now, what do you have actually is a right angle triangle, and I will bring it here again. So right angle triangle in which, what do you know is the hypotenuse being 18 meters and one angle is 30 degrees. And what we are looking for is the horizontal and the vertical component. So this is the vertical component. And this one here is the horizontal component. Why are those? Because this is along the vertical up and down, and this is along the horizontal left to right. And we have a right angle here. So now from a physics question, now it's turned into, okay, we will find the horizontal and the vertical component, or we will find the two sides of a right angle triangle. So if we are finding the horizontal component, the horizontal component is actually the opposite of the 30-degree angle. And the 18, which is the magnitude, is the hypotenuse. So now, what is the trig ratio that relates the opposite and hypotenuse? We will use SOHCAHTOA. So SOHCAH only for this case. So and CAH. So it's sine. So we'll have sine 30 degrees is equal to opposite, that is the horizontal component, over hypotenuse, or sine 30 degrees will be x that we are looking for over 18. If you use your calculator, you will find that x, let me bring the calculator here to you. 18 times sine 30 degrees is equal to 9. So x is equal to 9. Now, this is the horizontal component. And then we will look for the vertical component. Vertical component. So the vertical component is this part here, which in the relation to the given angle is adjacent. So then you will ask, what is the trig ratio, sine or cosine, that relates adjacent and hypotenuse? And it is cosine. So you will go cosine 30 is equal to vertical component over hypotenuse. And then from here, the vertical component, which is y, so cosine 30 is equal to y over hypotenuse, or over 18, over 18. Over 18, then y, if you use your calculator, you will find that y is equal to 18 times cosine 30 is equal to 15.6. 15.6. And you can write the units here. So now you found the horizontal and vertical component. But we are not dealing simply with the length of the line segment, but we are dealing with a vector that has direction. So the vertical component will be a vector as well. The horizontal component will be a vector as well, which will have the direction. So now the horizontal component that is going west will be not simply 9, but will be -9. Why -9? Because it's going west. So we have northeast, southwest axis, which are attached or are very similar to X and Y axis. And X and Y axis on the right are positive and on the left are negative. Y's in up are positive and down are negative. So when we have something or a component that heads toward the west, then will be negative, not direction, but negative statements. And now that we see the vertical component being going south, then the vertical component will not be simply 15.6, because this is turned out to be a scalar, not a vector. Well, but since it's going south, will be negative 15.6 meters. So when we are finding the components of a vector, we have to identify the sign even when the sign is a positive one. So let's suppose that we have this as a vector. We have a vector B that is 12 meters at 55 degrees north of east. So what we have is a vector that is creating with east axis, vector B, with a magnitude of 12 meters. So this is 12 meters and is creating an angle of 55 degrees. The very first step is we said create the right angle triangle that includes the given angle. So what includes the given angle is this one here. That means that we will have two components for vector B. The horizontal component and the vertical component. Now, you can bring this triangle on its own as a separate triangle, but you can work from here. So when we are finding the horizontal component, this is adjacent for that given angle. So is related to adjacent. Now, the hypotenuse is 12. So what is that trigger ratio that relates hypotenuse and adjacent is cosine. So cosine 55 degrees is equal to the horizontal component of vector B over hypotenuse that is 12. From here, the horizontal component of the vector will be 12 times cosine 55. If you use your calculator, if I bring the calculator here, then you will have 12 times cosine 55 and will be 6.9. So BH will be 6.9 meters. If we leave it like this, then we are not describing it as a vector quantity. But when we add the positive sign, then we are describing it as a vector quantity. And this is the proper way of finding the components. When we find the vertical components, so the vertical component is related to the opposite. So what is that trig ratio that relates the opposite and hypotenuse is sine. So then you will go sine 55 degrees is equal to the vertical component over hypotenuse, that is 12. From here, the vertical component will be 12 times sine 55 degrees. And if you use a calculator, you will see 12 times sine 55. Please make sure that the calculator mode is on degrees. Will be 9.8. So, but not simply 9.8, but will be positive 9.8 meters. I hope that you understand. We can go over in class with more examples like this. This is how you do find the components of a vector.